Hey everybody, Mr. Ray here with our next calculus lesson. We've just started the unit on curve sketching, so we're going to be looking to develop an algorithm by the end of the fourth lesson, or at the beginning of the fourth lesson actually, on how to incorporate tools that we've learned in advanced functions along with some calculus methods. So if you remember the last lesson we did, we were looking at the derivative of the function we're trying to sketch. If we take the first derivative, we were able to set that to 0 and find critical points. And once we found the critical points, we were using interval testing. We were able to find out if those critical points were local minimums, local maximums, or neither. Okay, so that's what the first lesson was about. That test that we did, I'm not sure if we actually called it this at the time. We call that the first derivative test. Okay, and I believe next lesson, not this one, but lesson 3 of the unit, we look at something called the second derivative test. Okay, to get a little more information about making a very accurate sketch of the curve. Today's lesson is it's a lot of review from advanced functions. So this whole topic here, vertical and horizontal asymptotes, this also could include oblique as well. This is how we identify what they are, and just kind of a refresher lesson actually. So just remember, a vertical asymptote, it's a line that the function approaches from, could be either side, and either goes up to positive infinity or negative infinity. As it approaches, it gets closer and closer to that vertical line, and it could be going, in different directions from either side, or it could be going in the same direction, meaning positive infinity or negative infinity. It doesn't really matter; it's still an asymptote. So, and then the horizontal asymptotes. Basically, it's a horizontal line that the function approaches on one side, maybe both, as x approaches positive or negative infinity. But again, it never quite touches, although that's a little bit of a lie. It could actually cross it and then come back towards it. So, all right, and the critical points, we learned that these were the points, at least from last lesson, these are the points that could be local mins, local maxes, or just they're points where the slope of the tangent is 0. Okay, and from those it could be a local min or max. Okay, I got some little definitions here. I don't think we really have to do that. Those two, you can just read through that. And local mins or maxes, you're not going to see those with polynomial functions. You're going to see all this stuff when you have a rational function. Okay, and if you remember, we'll talk a little bit more about this later on, but you have an oblique asymptote. That's the kind of the angled asymptote. It's not vertical, it's not horizontal, it's kind of some angle between. You have that when the degree of the numerator is exactly 1 more than the degree of the denominator. For example, if you have a quadratic over a linear, or a cubic over quadratic. Okay, if the degree is exactly 1 higher, you're going to have this. Okay, we do have an example where we find the oblique asymptote, but if you have any rational function, it's not listed here. If the rational function, the numerator's degree is less than the denominator's degree, then you will have a horizontal asymptote. Okay, so and this is kind of what we're going to have by the end of this lesson. We're not going to be we'll do bits and pieces of this, and by the time we get to the end of the unit, we'll be able to put the whole algorithm, meaning the checklist or the process to do a curve sketch. So that's the goal, and then at the end you can take any kind of, well, in our case, polynomial or rational functions, and come up with a really nice accurate sketch, better than what we did in advanced functions. So so after today, this will be our new algorithm. So this, what we're doing today is adding parts 1 and 5. We did point 4 in the last lesson, actually 3 and 4. Finding the x and y intercepts, I mean, that's, hopefully you've been doing this for years. If you want the x-intercept, you set y equals 0. If you want the y-intercept, you set x equals 0. We'll be doing this at the end of the unit, but I just want to hone the skills of the kind of the new things, or the ones that are maybe difficult from advanced functions. Okay, so what we're adding, the first thing we're adding is check for any discontinuities in the domain. That could be a hole, it could be a vertical asymptote. And if it's a vertical asymptote, we want to find the behavior at these points. Is it approaching, is it going towards positive or negative infinity? We have to be able to do that. And also the same thing with, well, actually that comes later. Intercepts, I just talked about. 3 and 4 was basically the last lesson. Test 5, that's the horizontal, or could be the, I guess, the oblique asymptote as well. What's happening with the function as x gets very, very big, and or really, really small, or really, really negative. So this would include, is there a horizontal or oblique asymptote, and if so, what direction, what side of that asymptote are we approaching from? Okay. And then this one was also part of the critical points. How do we determine from the critical points, from the interval table we build, what is actually happening with the function? Is it local min, local max, or neither? And then we put all this together and we sketch the curve. Okay, so this list is not complete. As you can see, we got, so far. We'll be adding a couple new things in the next lesson, and then put everything together. Okay, so I've got, let's see, 4 examples we're going to do. So a lot of this will be review from the advanced functions. So if you remember that, not much new here, but you do have to know it for this course as well. So determine any, so this is very specific. This isn't a curve sketch. Just determine any vertical asymptotes of this rational function, and describe the behavior of the graph of the function for values of x near the asymptotes. So we just call this vertical asymptote behavior. So the first thing we want to do, if you remember, we have vertical asymptotes whenever the denominator is 0. So we should factor the denominator so that we can set each factor to 0 and then find the asymptotes, vertical asymptotes. So this is a fairly straightforward one. This is going to be factoring to x plus 2, x minus 1. Okay, and then from that, I mean, you don't have to put a whole, you can leave out a lot of stuff that you might have done in advanced functions. You can just say, okay, from that I know that if x is negative 2, this will be 0. If x is 1, this will be 0. Either case, I have a vertical asymptote. So I have a vertical asymptote at x equals negative 2 and also x equals 1. Okay, so we found where the asymptotes are. Now it's looking at taking each of those and determining the vertical asymptote behavior from each side. Okay, so if you remember this, and I know teachers will do this as, slightly different ways depending on the way they like. Of course, you can do it whatever way you did in advanced functions is fine with me. But if you're starting from scratch or you've totally forgot, what we do is we have kind of 2 statements for each asymptote. So we have x equals negative 2, and we also have x equals 1. Okay, so for each of these, we're going to do some analysis as x is approaching the asymptote from the left or from the negative side. Where's this function going? And also the same thing as x approaches -2 from the positive side. Okay, and you can see we're going to branch out for this vertical asymptote as well. All right, so the way I prefer this, and again, this is, subjective. So the way I do this, and this is, you pretty much have to use the factored form. So if I put something smaller than -2, for example, -2 maybe I'll put in brackets here, -2.01. It could be like a test value because it's more negative than -2. If I plug that back into these factors, I just want to know what sign I'm going to get here. Okay, so on the top, there's no x. So if I'm plugging in -2, it doesn't really matter what x is because the top is always 1. So the top is always positive. Okay, and then in the bottom I look at each factor here. What's the sign of each factor? If I plug in -2.01, well, this one's the critical one because -2.01 added to 2, that would be a very small negative value. And here, -2.01 minus 1, that's going to be a large negative value. I don't know where I put a 1 there. You're just looking for the signs of each. It doesn't really matter the value. So we have 2 negatives on the bottom, and that is going to approach. That's going to approach a positive over a positive. And the only 2 options where this can go is positive infinity or negative infinity. So if you get a positive result, that means f of x is approaching positive infinity as x approaches -2 from the negative side. If we do the same thing as we approach from the positive side, so in this case our test value would be -1.99. You could use your own value. So in this case you're going to have f of x equals, so f of x approaches, and then on the top you're still going to have positive because 1 doesn't change. It's always going to be positive. And then if I plug in -1.99 here, now this is actually going to be positive. And the second one is still negative, -1.99 minus 1. So now the sign is going to change. So that is approaching negative infinity. Okay, so that's the behavior at the vertical asymptote x equals -2. Now we do the same thing for 1. So as x approaches 1 from the negative side, as x approaches 1 from the positive side, what's happening with the function? Is it approaching positive infinity or negative infinity? Okay, so exact same process. So this, as x approaches 1 from the negative side, this test value could be 0.99. And while we're doing this, 1 from the positive side could be 1.01. Okay, so I always do it like 1/100th to the left or right of the vertical asymptote. Okay, but that's just my choice, my personal way of doing it. Whatever way works for you is good. Okay, so on the top for both of them, you're going to have positive because of the 1. And then if I plug in 0.99 here, okay, well that's going to be positive, and this will be small negative. So I have a positive negative. So that means it's approaching negative infinity as x approaches 1 from the negative side. And for this one, as x approaches 1 from the positive side, if I plug in 1.01, well, that's definitely positive, and that's a small positive, but 2 positives nonetheless. So overall, that's going to be approaching positive infinity. Okay, so that's a reminder first of all, how to find the vertical asymptotes. Factoring is always a crucial skill here. And then testing the behavior of each asymptote from both sides, from the negative side and from the positive side. Okay, and then all we're interested in is the sign, because it's either going to positive infinity or negative infinity. Okay, so hopefully that reminds you how to do that. Here we have determine the end behavior. So end behavior, that basically means about horizontal asymptotes. Okay, so if I write the function out again, this is a rational function. 3x plus 5 over 2x minus 1. Okay, now this is the official way to find the horizontal asymptote. It's the limit as x approaches infinity. Well, this is checking what's happening on the right side of your graph. Of 3x plus 5 over 2x minus 1. Now this is the part you don't have to do every time. I'll just show you the shortcut at the end. So what we do is we're going to divide everything by the degree of the highest degree of any term. So in this case we're going to divide everything by x. So what we get here is 3x over x minus 5 over x. Okay, I split them out. And then 2x over x minus 1 over x. And you can see what happens with this that term there. The x's cancel out, so it's 3 minus 5 over x, and 2, sorry, that should be a plus. Okay, and a plus 5 over x, and a 2 minus 1 over x. And as x gets really, really big, these terms actually go towards 0, because 5 over a million is getting pretty close to 0. Okay, so what happens is both of these terms approach 0, so the overall limit is going to be 3 over 2, because these two basically cancel out. Okay, so how do you do this really quickly? Well, you look at, in this case, the degree is the same, and so if you have the same degree for a rational function, the horizontal asymptote will be y equals, and then it's the ratio of the leading coefficients. So in this case it's 3 over 2. So right away we can say the horizontal asymptote, and it's very important not to say it's 3/2, it's y equals 3/2, just like for the vertical asymptotes, you say it's y equals x equals whatever it is. It's not just the number. Okay, it's the equation of a line. In this case it's a horizontal line. So now we have to do the behavior. So horizontal asymptote behavior, and this is a little bit like vertical asymptote behavior, but it's done a little bit differently. So instead of just saying we're not trying to get really, really close to a value of x, we're just trying to get humongous values of x, positive and negative, and see where is this function headed towards. So and what we want to know is it approaching this asymptote from above or below? That's the goal here. So again, we're going to do two branches of this as x approaches positive infinity and as x approaches negative infinity. So what's going on? Now what I do, I have my own personal choice again. I just plug in for it as x approaches positive infinity. I'm just going to plug in x equals positive 100, and as x approaches negative infinity, I'm just going to plug in x equals negative 100 and see where we're getting close to. Okay, so this is going to say f of x is equal to, well, this would be f of 100 actually. F of 100, or the limit, approximation of the limit, is going to be, if I plug in 100 into the original function, that's going to be 300 plus 5, so 305 over, and 100 here would be 200 minus 1, that's 199. Okay, and if I evaluate that, that's going to be 1.53. Okay, so now what I do is I compare, well, 1.53 is where we are at x equals 100, and the actual asymptote is 1.5. So 1.53 is above the horizontal asymptote. So that's the goal here. So this will be my summary, the important stuff. As x approaches positive 100, y approaches 1.5, which is the asymptote, and it approaches it from above. So I put the plus there. Okay, and then I do the exact same thing. Plug in negative 100 for x. If I do that, I get negative 300 plus 5, so that's negative 295. And negative 100 on the bottom, that's negative 200 minus 1, negative 201. And that's approximately equal to 1.4. These are approximates. That's approximately equal to 1.47. And you can compare the 1.47 to the 1.5. You see, well, that's below the horizontal asymptote. So the summary is, as x approaches negative infinity, y approaches, and it's always going to approach 1.5, but we want to know from above or below, and 1.47 is below 1.5. So we can now use these to show the end behavior, or the horizontal asymptote behavior. To me, those are interchangeable. Although end behavior could apply to an oblique asymptote as well. Okay, so that's how you do the end behavior, or the horizontal asymptote behavior, and we just did the vertical asymptote here. Okay, so next question. For the function f of x equals 3x over x squared minus x minus 6, determine the equations of all horizontal and vertical asymptotes. Sketch the graph to indicate the behavior of the graph around the asymptotes. Okay, so it's really combining example 1 and 2 and then adding in a little sketch. Okay, so it's going to be a little cramped in this answer, in the space provided. F of x equals, and again, we're going to factor the bottom. So this is a fairly simple factor, and that's x minus 3x plus 2. So that means we have vertical asymptotes at x equals 3 and x equals, sorry, that's missed a sign there. Yeah, plus 2. So vertical asymptotes at negative 2 and positive 3. Doesn't really matter the order you put it. And so now I'm going to do a little bit quicker job than I did in example 1. So I'm just going to say as x I'll just write out what I'm going to do first, and then I'll do it. So as x approaches 3 from the negative side, f of x approaches something. Now we know it's going to be infinity. We just have to know, is it positive or negative. So I'm going to just write out all 4 of them. So as x approaches 3 from the positive side, f of x approaches which infinity. That's one of the reasons I always put plus or minus infinity. I don't assume that infinity is always positive, because of a situation like this, I want to fill this in, and I know I'm not done if I see a blank there. Okay, and then for the other, for negative 2, as x approaches negative 2 from the negative side, f of x approaches which infinity. Same thing for approaching negative 2 from the positive side. Okay, now, so I'll do the plus minus stuff in my head. If you want to do it the way I did in example 1 or your own way, that's fine. But for example here, so 3 from the negative side, that's like 2.99 would be the test value. So 2.99, that means the top is positive, positive, negative, positive. And all I really need to do is count up you know, how many negative signs do I have? And that's going to tell me the overall sign. So in this case, I got one negative sign. So overall, the result will be negative. So the function's approaching negative infinity for this branch. If I'm as x approaches 3 from the positive side, I can use a test value 3.01, and you can see that's positive, small positive, positive. So they're all positive. So overall, the function's approaching positive infinity. Negative 2 from the negative side, that'd be like negative 2.01. Okay, so negative 2.01, that's negative, and that's negative. So I have 3 negatives. So overall, the value of the function is negative. Okay, and then the last one, negative 2, x approaches negative 2 from the positive side, so that's negative 1.99. So negative, negative, positive. So overall, that becomes positive. So I've got all 4 of my vertical asymptote statements that I will then use for the graph. Okay, so we're done all the vertical asymptote work. Now we do the horizontal asymptote. Now here's where you're not going to want to use the factored version when you do the horizontal asymptote, because you really want to see the degrees. Of course, you could see them here and work it out, but it's already done. So the degree of the denominator, which is 2, degree of the numerator is 1. So since the degree of the numerator is smaller than the denominator, we know that the asymptote will be y equals 0. Okay, so I'll just write that here. Since you don't have to put this, all that we really need you to do is put the equation. Since the degree of the numerator is less than the degree of the denominator, so this will always be true. The horizontal asymptote is y equals 0. Okay, if the degrees were the same, then that's where you take the ratio of the leading coefficients like we did in example 2. But since its degree of the denominator is higher than the degree of the numerator, we always know it's y equals 0. Now for the behavior, I should have put behavior here, but you guys knew what I was doing, I'm sure. So as x approaches, let's do positive infinity first. And as x approaches negative infinity, we'll do that second. F of x. So this is where you would plug in okay, now there's a little trick here. You can't do this all the time. Since the horizontal asymptote is y equals 0, the only thing we're interested in with this function is the function going to be positive or negative? And that tells us if it's above or below 0. Okay, so we can do this little trick when the degree of the numerator is less than the degree of the denominator. If they're equal, you can't do this trick. You have to look at the actual number like we did in example 2. Okay, and I've had a lot of students fall into that trap where they do this positive negative test when the horizontal asymptote is something other than y equals 0, and it won't work. Okay, so all we want to know is the sign. So if I plug in this case, plugging in x equals 100, okay, I go back here, that's going to be positive here, that's going to be positive, that's going to be positive. So we know that f of x is approaching 0 from the positive side. Okay, and if we plug in x equals negative 100, we have negative, negative, negative. We have 3 negatives. So overall, the function is going to be negative, so it's approaching 0 from the negative side. Okay, so we've done all our work. Now let's just do the sketch. This will be a very crude sketch. Okay, so here's your axes. Okay, so the first thing we can draw in is our horizontal asymptotes. Okay, and if you remember, doing those we do like dashed lines. So this is -2, that's 3. So we have a vertical asymptote there, and one there. And this is where it's kind of hard to do this on a sheet of paper with a pencil, but the horizontal asymptote is right along the x-axis. Okay. Now here's hopefully you'll remember how to do this. So if I'm looking at, first of all, let's do this x equals 3. If I'm approaching from the negative side, the function's approaching negative infinity, so that means I can draw a little arrow there. I'm going to join these all up at the end. If I'm approaching from this side, it's going towards positive infinity. And then over for negative 2, if I'm approaching from the negative side, it's approaching negative infinity. From the right side, approaching positive infinity. And then the end behavior, as f of x approaches positive infinity, the function is approaching 0 from above. And if I'm going from in the negative side, it's approaching 0, or the horizontal asymptote, from below. So now you kind of put things together here. So if I'm working left to right, I can see I've got my 2 arrows in this little quadrant area. So this is where you just have to know that for rational functions, it's going to be, we don't really know what's going on in terms of values, but we know that it's going to, these are 2 asymptotes and it's approaching from both sides, so it's going to look like that. Same thing over here. If I go to the other end, I'm going to have my little quadrant graph like this, and here I do know that this is coming down, this is coming up. Okay, as to where it actually crosses, this is what, this would be where knowing your x-intercept would be very helpful. If you remember, the way we make that value is, if you want the x-intercept, we let y equal 0, so 3x equals 0, so we know there's an x-intercept there, so we can plug that in. Okay, so that's a rough sketch just looking at the vertical horizontal asymptotes. Okay, so hopefully that reminds you how to do that. We'll do the last example, which is an oblique asymptote. So basically, here's the function: determine the equations of asymptotes, sketch the graph to indicate the behavior of the graph around the asymptotes. Okay, so kind of give you kind of ruin the surprise here with the heading. This is going to be oblique, but you will know that's oblique because the degree of the numerator is exactly 1 more than the denominator. So this is degree 2, this is degree 1. 1 higher means it's oblique. Okay, so when you have an oblique, that basically replaces a horizontal asymptote with an oblique. Okay, you can still have vertical asymptotes because that's totally just depends on the denominator being 0. So in this case, might as well put the vertical asymptote first without a whole lot of work. We don't even have to factor this. That will be x equals -1 is your vertical asymptote. Okay, now if you remember how to do this, you can either use synthetic division or long division. I'll do the long division just as a reminder. So it's basically, there's your division line here. So it's 2x squared plus 3x minus 1 divided by x plus 1. Just a reminder, if you have to have a placeholder for every degree of the equation. So for example, if this had been 2x cubed plus 3x minus 1, you notice there's no x squared term. I would actually have to write in plus 0x squared if I was missing that degree. Okay, so the way this works, you basically say to yourself, what do I have to multiply x by to get 2x squared? And that would be 2x. So I put the 2x kind of in the x column. Okay, and then I actually multiply both of these terms by 2x. I get 2x squared plus 2x. Draw a little line under, and then we subtract down. Okay, and this has to I mean, the whole reason why you pick 2x is because that's going to eliminate the 2x squared when I subtract. So nothing there, and then 3x minus 2x, that's just going to be 1x or x. And then I bring down the minus 1. And now I do the same thing. What do I have to multiply x by to get x? That's just positive 1. So I have x plus 1 when I multiply this by 1. And now I subtract. I get 0, negative 1 minus 1. That's not going to be 0. That's going to be negative 2. Negative 2 is the remainder. You can't go any farther because you're down to constants. Okay, so that's the remainder. So the result that you got up here, that's actually part of the equation. So your oblique asymptote is going to be, and this is important again, this is y equals 2x plus 1. Okay, and there's our vertical. So we've got our two asymptotes written up there. Now, there's different ways of doing the oblique asymptote behavior. One thing that I've done recently in the last 5 years when I do this is a slightly different way. So I could rewrite this equation of the function, because I already divided it out and I got 2x plus 1 as an answer, but I also had a remainder of negative 2. So that remainder is going to be like a minus 2 and then over the x plus 1. Okay, so this thing here will be the remainder if I do the division. Okay, so what I'll do for the oblique asymptote here is, again, we want to break it into the two parts. As x approaches positive infinity, what's happening with f of x? F of x is approaching. Now, this is going to be different now because it's not approaching a value like a constant like it did with horizontal asymptote. It's actually approaching the asymptote, which is 2x plus 1. Okay, but we want to know, is it approaching it from above or below? So I'll show you how to do that in a second. So I'll write out the other statement for the negative infinity. So f of x will also be approaching the asymptote 2x plus 1, but is it going to be from above or below? Now, one thing you could do is you could just plug in a value and compare it to what the oblique asymptote would be at that x value and see if it's above or below. That's the way I used to do it. But now, if you look at that remainder part, okay, if I plug in, it doesn't even have to be a super high value. If I plug in, say, x equals 10 to simulate approaching positive infinity, what's this remainder going to be? Well, that's going to be, minus 2 over 11. Okay, so that's actually going to be below this asymptote, because if I plug in 10 for x, it's going to be less, the f of x value will be less than 2x plus 1. So it's, the way I could write that is it's approaching the asymptote, the oblique asymptote, from below. Okay, if I do the same thing for approaching x approaches negative infinity, so let's plug in negative 10. So negative 10 here would be minus 2 over negative 11, or plus 2/11. So in this case, the value of the function will be slightly above the asymptote. Okay, so here I can put a plus. For me, that's the best way of doing this, because you're really just seeing, am I adding or subtracting, is the value above or below this asymptote here, and you get this directly from your long division or even your synthetic division. Okay, so now when we do a sketch, okay, now let me maybe make this lower because we want to draw our oblique asymptote. So you have to go back to your linear graphing. So 2x plus 1, I'm going to draw that in first. So there's my y-intercept of the oblique asymptote, 1. and then it goes over 1 and up 2, so there's an oblique asymptote. Again, a dotted line that looks something like that. Has a slope of 2, y-intercept of 1. Okay, and then I've also got I've got my vertical asymptote at x equals -1. So I'll draw that through there. So that's going to be slightly, well, this is a sketch, so I'm not going to be too worried. Okay, so there's my vertical asymptote, there's my oblique asymptote. Now I did the behavior of the oblique. So as f of x, as x approaches positive infinity, the function approaches the asymptote from below. So that means I know the function is going up towards this oblique, okay? And on the negative side, it's approaching from above. So I basically got some kind of arrow coming up like this, okay? Now I guess I didn't do the vertical asymptote behavior. You could do that very quickly. You're going to see that, I'm not sure why I didn't do that. Yeah, why don't we do that? So vertical asymptote behavior. And there's only one vertical asymptote, so it's pretty quick. So as x approaches -1 from the negative side, f of x approaches, and also as x approaches -1 from the positive side. So remember, these are going to be approaching infinity. Is it positive or negative? So if I plug in, okay, so -1 from the negative side, that's -1.01. This is, okay, I see why I didn't do this, because we didn't really factor this on the top because we didn't have to. But definitely on the bottom here, that would be, that would be negative on the bottom. So you could actually work this out. It's not quite as easy as when it's factored. Let me just skip to the result. So this would be approaching from the negative side. It's going to approach positive infinity, and from the positive side negative. So I'm going to have a line approaching from that side and a line approaching from this side. And now you can just see, and now you can kind of do a sanity check, like, can I join these two lines together without crossing an asymptote? And yes, I can. Sometimes you have to slightly modify your lines. So it looks something like this on that side, and then this side would look something like this. Okay, so this is kind of a strange looking graph. It's because it's oblique asymptote. You're going to get this weird behavior. A lot of times in oblique asymptote, you're going to have graphs in this little pocket area and this pocket area here too. But as you can see in this example, you've got the kind of swooping long curve that approaches on these obtuse angles. Okay, so hopefully these examples have reminded you how to do vertical, horizontal, oblique asymptotes, how you do the end behavior and vertical asymptote behavior, and how that information will help you have one component, two components of doing some curve sketching. Okay, so in the next lesson we're going to be doing something brand new, which will be looking at the second derivative to get some more information. So in the meantime, we will be having 3 lessons this week. So I'm actually going to post the second lesson Tuesday and then the third lesson on Thursday, just so we can finish off the curve sketching this week, have one assignment on it, and then we'll finish off the course with the applications and optimization. So not sure how many lessons that'll be. We might be able to finish it off in 1 week. We'll see how it goes. Okay, so hope you have a good day, and we'll talk to you soon.